All right, we're chugging along here in the API architecture track, and now we've got Satya Jayanti, who is with a little company called Red Hat. I think we've all heard of it. So, Satya, I'd love to have you talk us through today application connectivity in a multi-cloud environment.
Thanks, Christine. Nice to be in API Days. And yeah, from a little company called Red Hat. My name is Satya. I'm actually a product manager for cloud native API management here at Red Hat. What I want to talk about today is application connectivity, this whole merging of APIs, service mesh, Kubernetes, in the cloud native space, and how we need to think about connecting to your applications on the cloud in a different way and hopefully present some new architectures and something that you could think about. So what is cloud native application connectivity? Applications that live on the cloud are called cloud native applications. So for now, what cloud means is containers and Kubernetes, right? That's kind of become the standard of what cloud native computing is nowadays. So when you deploy your application onto a cloud platform, onto Kubernetes, what you need is, what business needs is it derives value from it. It kind of doesn't matter where your application stays, but it matters to them what value it brings. And the value that they want to see out of adapting cloud native technologies is the ability to connect and access these applications across all of their environments over the internet into different clouds that they're using or on-prem environments that they're using, and have it done at a greater speed than they were used to in the traditional data center based environments by adapting these cloud technologies. So that's what the businesses want to get out of your cloud native applications, and that's where application connectivity in a cloud native world would help. And similarly, for the IT, it is to make their life easier going cloud native, right? What we are doing here is trying to bring companies into this new modern cloud native world, and the way to do that is to standardize and bring a consistent way for them to configure, secure, and consume all of these applications that are interconnected and available on a cloud platform, and provide the best of class operational abilities for them. Right? So what are then the elements of modern application connectivity? So what you see is cloud native adoption requires connectivity, right? What I mean by that is, just because an application exists on the cloud doesn't automatically mean you derive any value. If an application is deployed on the cloud, exists on the cloud, it needs to be able to connect and talk to either your other applications or be reachable by your consumers. And that's when a business derives value out of it. It should be able to be accessed and consumed. Similarly, where we are seeing currently is the combination of concerns that you see when you provide an application on the cloud is suddenly your DevOps teams, your admin teams, and your developers together need to worry not just about application concerns, but network concerns as well. What happens, how do I make, first of all, a connection possible to my application, a URL, a way for my consumers to reach it, or a connectivity between services that need to talk to each other to provide some sort of a business solution. And at the same time, as an application developer, I need to be able to say, what are my business concerns, what access level, what security, what rate limiting do I need to apply, and how do I combine them into a modern API product and an API platform, right? So there are multiple concerns that come together when you're trying to deploy and derive value out of the cloud native architecture. And you need to extend beyond just the APIs and think about any endpoint that exists on the cloud, whether it is your APIs, whether it is your events endpoints or your Kafka endpoints, whether you are following a microservice architecture or an event-driven architecture, any service, any application that uses services deployed onto a Kubernetes platform should be able to have a standardized way to address these connectivity concerns. So let's talk about some of these concerns in a more broken down way, right? So cloud native application connectivity, then we could say it consists of three different layers. So at the bottom is the networking layer. Usually the Kubernetes platform on which you deploy any standard enterprise Kubernetes platform will provide you these functionality that you would need to set up as an administrator of your Kubernetes platform. So things like traffic management, inter-service connectivity, your DNS routing, your global load balancing across your environments, or access to your applications that are running in a cluster or in multiple clusters within the same domain. Right. And then you come to the next layer, which is your application layer. And in your application layer, you worry about you have your connectivity now. You're worrying about the next level. My URL is reachable, but then I want authentication. I don't want this to be open to everyone on the internet. I want authorization. I want people with the right roles to access the right paths, or have the right restrictions put in place. And then rate limiting, whether it is due to some platform constraints, or whether it is due to constraints to do with the plan that the user has. Right. So these are some of the constraints, and this is where we see a lot of combining of concerns between service mesh and service mesh products out there, and API management, API gateway products out there. So you could use one or both to provide these. And then you have the purely API as a business concerns, which an API product owner would be more worried about. Things like, how do I make my API product and monetize my APIs, provide a developer portal and make my APIs accessible to my users, provide analytics, and provide some sort of a complete full lifecycle API management for myself. And these are things that only an API management platform can provide. So as we can see currently, as things stand, we have multiple layers, and for each layer we have the right platform and the right control plane which provides the right solution. Right. So let's dig into each of these concerns a little bit deeper, and then towards the end of my talk, I'll show you how in a multi-cloud world these concerns kind of combine together and make things even more complicated. At a simple level, traffic to applications in a cluster requires you to set up an ingress, right? So ingress is a URL that is exposed by Kubernetes to allow outside services to outside API consumers to request route the request to your application container, right? So the container would have a service that allows you to then route it to your appropriate exposed endpoint onto your container. And so what you immediately see here, the levels of abstraction that you are adding on top of Kubernetes for a request to come to your exposed endpoint within your container, right? So there is a service that virtualizes where your application is running within a cluster, which particular node, which particular pod, and then there is ingress, which worries about how do I route these external requests to an internal service endpoint, right? And then similarly, if you want to take traffic outside of your Kubernetes environment, again from your application container, you want to request an external service, say whether it is a database that is running outside of Kubernetes, or whether it is some sort of an application that you have hosted in your data center, which is a non-containerized application. In this case, again, Kubernetes allows you to use an egress, a way for you to provide a sort of a registry which allows that particular table to translate the request from the container endpoint that you want to access to the external service that you're going to access it. Right. So again, another level of virtual endpoint at that stage. So what you can see is Kubernetes kind of provides you with this sort of an abstraction layer, so that as an application developer, you don't need to worry about a lot of these networking and access related activities. You just worry about exposing your application endpoints as you would do in a local environment, and once you deploy it, the platform would take care of it. things become a bit more complicated when you move into a multi-cluster world. So here I'm assuming both of these different clusters are running in the same cloud environment, but I want to have two copies of the container, right, application, but both running in different clusters, maybe for different reasons. I want to do some disaster recovery. I want to have an active mode of HA and DR available. I want to distribute load across clusters, due to geographical limits or various reasons. And so what I then need to do is depend on an external load balancer that would provide access to these particular ingress points. And then at this stage, if you are using any of the cloud vendors, then they would provide a load balancer for you, which allows you to then have a multi-cluster connectivity for ingress taken care of. What happens in multi-cloud? Again, you get one more layer of complexity. You got two different cloud providers. You got to distribute across the load to each of these applications running in each of these clusters inside the cloud provider. But then in order to do this, your DNS and load balancing can now not be connected to a single cloud provider because it wouldn't work outside, which means you would now need to externalize DNS load balancing and global load balancing architectures as well. And so as we begin to add more complexity into our environments, we begin to see that there's levels of abstractions, and the level of places in which we need to configure things increases exponentially. Now let's look at service to service connectivity and the concerns there. So if we look at service traffic within a cluster, then Kubernetes provides you with that service to service connectivity out of the box, and using internal cluster IPs. It's all good, all easy. When you have to go across clusters, again, if you have to follow the standard way, you have to follow, treat each of these clusters as isolated environments, which means have to worry about the egress and egress before the services can talk to each other. Or you need to consider some sort of an external solution which allows you to tunnel across clusters, right? So which is basically either to treat both of these clusters as a single virtual network, or to provide a layer 7 level of connectivity to treat these services and service endpoints hosted outside your cluster as if the traffic is coming from inside. And there are very good solutions in this place. But again, if you treat this as a standalone problem, you're trying to solve this in a standalone way. Okay, and then that is not even coming to what the application concerns are, right? So if we come to the application concerns, as we have seen, we can use API management and service mesh. With API management, again, you would have to have an API manager control plane where you define your API products, your plans, and your rate limits and authorization rules and everything. And at your data plane, you would have an API gateway, which for a lot of vendors typically runs as a cloud hosted application, which means that again, to route traffic into it, you're going through an ingress to reach the gateway service, which would then apply the authorization and rate limiting rules before routing the request back to your application, right? So as you can see, more levels of abstraction, more hops before you reach your backend. Right? And similarly with service mesh, you have another control plane to deal with, which is istio-d, and then you have to specify your gateway configurations and your policies, which are enforced with sidecars, on each of your containers to allow for the traffic to flow through in your data plane. Okay, so if we look at what we have achieved, if we want to do real multi-cloud today with all of the layers, each of those layers is very good, and each of the technologies is good and necessary for what you have to do. But when you have to think of a network administrator or a developer today trying to provide access to their applications on a multi-cloud environment, then the levels of abstractions and the levels of configurations and the different control planes that they need to deal with is complex. So you have DNS continuous load balancing, you have Kubernetes control planes, you have the API managers, you have istod, and maybe more, right? Observability layers, and maybe you're adding eBPF or other things, right? So it just gets more and more complex, and so your architecture kind of begins to break down a little bit. So what I want to talk about today is how we can bring this together. And there's a lot of use cases that have given us an opportunity to think along this way, right? So one of the first thoughts is, what if we think of all these as not as separate problems and separate concerns, but think of it as a unified gateway, right? Instead of abstracting at the Kubernetes cluster level, what if I abstract it as a gateway? Treat all traffic that has to reach my application as a gateway problem to solve, right? And then so what I do then is I provide a comprehensive managed connectivity, having both network and application level access control to my cloud native applications, right? And then what I can also do if I do that is, if I only concern myself with gateway, what about microservice architectures, right? What about east-west connectivity, right? I cannot just say I'm solving your ingress problem and leave your egress problems or your service to service problems. I have to consider all of these problems together, right? There have to be one solution and one way that you can solve these problems. And that's the other advanced use case that we could think of. What about bringing transparency to your multi-cluster, right? If we can distribute our load across applications, what's to stop us from doing it on the fly? What's to stop us from saying, hey, instead of me deciding that I have to distribute load to these clusters, why can't I just have these run as just like Kubernetes runs the pods? If I scale it up to two, it just has two pods running. If I want to move a pod across to a different node, it just automatically configures the service endpoint to route my traffic to it. So why can't I do it transparently at the multi-cluster level when Kubernetes allows me the ability to do it at the cluster level, right? And so it's not just about moving that particular application to a different cluster or even a different cloud, but also rebalancing all of the dependency services, all of the other traffic. If, for example, if you're using a mesh and you have to reconfigure the service endpoints because now one of the services has changed to a different cluster, we need to have an ability to do that as well on the fly. Right. Similarly, authorization rate limiting, right? Application level concerns, providing this security for your applications that are running in a multi-cluster, multi-cloud environment using a single standard way and a single standard configurations, right? Instead of running multiple instances of gateways that have to each of those configured separately, or each of those applications having independent rate limiting. Why can't I have a global rate limiting? Why can't I have a global authentication and authorization access? Whether you move your application from one cloud to other, one cluster to other, whether it is transparently load balanced or transparently migrated, it should be possible to have all of those configured together, right? And then finally, we have the edge and hybrid scenario, right? So what happens if instead of me distributing this across only clusters and thinking about only clouds, what about some of my applications or traffic is coming from edges, my network edge, or a hybrid scenario where instead of just considering multi-cloud, what about we consider multi-cloud plus a data center, or a mix of both, or SaaS hosted clouds and not Kubernetes clouds, right? So these are the kind of concerns that allow you to think beyond the current architecture of a layered approach that we see today, right? And so to bring all those concerns together then, right? So you have your API management concerns, and on the left are the higher level concerns that you have with your your business level concerns, as we have seen, and then your application level concerns with rate limits, policy, and security, and your service mesh, of course, which provides all of the policies that you need to make microservice architecture. And beyond that, the application connectivity concerns that I've said. And as you move from left to right, your target user changes from purely the API providers and the consumers to being more lower level, more catering to developers and your DevOps engineers and your system administrators, right? So this continuum is what we need to solve. And so we have the application connectivity capabilities then. So it's the same diagram, it's the same layers, but what application connectivity kind of tries to solve is map all of the concerns that you have seen onto this whole provide another layer, an abstraction that allows you to solidify onto a single control plane and solidify onto a single data plane that allows you to then free your higher level architectures like API management or service mesh to focus on solving the policies that they want to solve rather than trying to solve the network complexities. Okay. So this is what a hybrid application connectivity will be all about then, whether you're running in multiple clouds, multiple apps running, microservice architectures running, whether there are users that are trying to access ingress or external services. For all of these in a multi-cloud environment, you should be able to solve with ingress and egress concerns. You should be able to solve those cross-cluster concerns. You should be able to solve global application security and rate limiting policies, and you have to do the ability to do all of those things together, right? And what I'm going to show here is some further reading that you can do on these topics. So I have provided some articles and some of the exciting projects that are going on in our open source communities. Red Hat is contributing to a lot of them. Do check them out and do contribute. There are exciting products that are coming out in this space to solve this problem very soon. Okay.
All right, great. Satya, thank you so much. We only have a few minutes here, but I love your approach in terms of simplifying, because there's so much complexity, so many choices, so many data sources in that. I'm curious, a question came in around how do you manage when there is a complex environment? Do you start taking things apart? Do you look at it from blank slate? How do you address things that you may not have been there to invent, but yet you have to manage and run and re-architect?
Absolutely, and that's a very good question, right? And the thing to think about here is we are not trying to reinvent the wheel here, right?
Mm-hmm.
What we are trying to do is use the existing Kubernetes approach, what Kubernetes does to a single cluster and does it very well. We want to take the same knowledge and apply it multi-cluster and multi-cloud. So the same Kubernetes objects, custom resources that you see, the same way that it propagates its configurations across the different nodes in a cluster, we want to take the same knowledge and abstract it to the next level. And so that's the approach that a lot of these projects that I'm showing you are taking to make it easier and more intuitive for developers and administrators who are used to working in the Kubernetes world over the last few years.
Right. Okay. And then also, just quickly, you were one of the few people that talked about east-west traffic, and that, right, I think it's easy to not dismiss it, but not take a different look at that. So just love to hear you talk about that. And do you treat it differently than north-south? How does that look in the environment?
Yeah, so I showed a few of the approaches that you could do with east-west traffic. Within a cluster, it's easier, right? You have your service mesh, and you have your policies configured, and you allow that east-west traffic to flow. The network capabilities are provided by Kubernetes. Yeah. When it spreads across clusters, and there are service mesh solutions out there that spread across clusters, but then there is another level of abstractions that they put in, right? They have this abstraction of namespaces into workspaces or other custom resources that need to worry about. And tunneling approaches, like I talked about, projects like Scupper and Submariner that are trying to solve this space. And what we think is, a combination of all these is needed.
Mm.
And so the abstraction that we are trying to put in is, again, going back to the basics of what Kubernetes does best, learn from the Kubernetes resources and custom resources, and apply the same principles to the next level of abstraction. So abstract out the whole tunneling and treating external services as you do internal services, and solve that problem in a uniform way.
Okay.
That's what I want.
Yeah. I don't know if you were able to listen to the other presenters today, but it all holds together, right? In terms of Chris talking about open APIs or for open banking. Asanka talked about the service mesh, which you touched on as well. And then Arlemy talking about, how to build API first in a culture even. And now you're coming in with how do you make it all work together in a seamless and less complex way. So I love all that together. And I want to thank you so much. We are